Traditionally, relays use an electromagnet to mechanically operate the switch. However, newer versions will use electronics, such as solid-state relays. Relays are used where it is necessary to control a circuit using a low-power signal, or where several circuits must be controlled by one signal. Relays ensure complete electrical isolation between the controlling and the controlled circuits. Relays are often used in circuits to reduce the current that flows through the primary control switch. A relatively low amperage switch, timer, or sensor can be used to turn a much higher capacity load on and off. We'll see examples of this a little later in the video. There are two main circuits in the relay, the primary side and the secondary side. The primary circuit provides the control signal to operate the relay. This could be controlled by a manual switch, a thermostat, or some other type of sensor. The primary circuit is generally connected to a low voltage DC supply. The secondary circuit is the circuit which contains the load which needs to be switched and controlled. When we talk about a load, we mean any device that will consume electricity, such as a fan, a pump, a compressor, or even a light bulb. On the primary side, we find an electromagnetic coil. This is a coil of wire which generates a magnetic field when current passes through it. When electricity passes through a wire, it creates an electromagnetic field. We can see that by placing compasses around the wire. When we pass a current through the wire, the compasses change direction to align with the electromagnetic field. When we wrap the wire into a coil, the magnetic field of each wire combines together to form a larger, stronger magnetic field. We can control this magnetic field by simply controlling the current. By the way, we have covered how solenoid coils work and even how to make your own solenoid in our previous videos. Do check that out, links can be found in the video description down below. At the end of the electromagnet, we find the armature. This is a small component which is pivoted. When the electromagnet energizes, it attracts the armature. When the electromagnet is de-energized, the armature returns to its original position. Typically, a small spring is used to achieve this. Connected to the armature is a movable contactor. When the armature is attracted to the electromagnet, it closes and completes the circuit on the secondary side. We have two types of basic relay, the normally open and the normally closed type. There are other types of relays, and we're going to look at these a little later in the video. With the normally open type, no electricity flows in the secondary circuit. The load is therefore off. However, when a current is passed through the primary circuit, a magnetic field is induced in the electromagnet. This magnetic field attracts the armature and pulls the movable contactor until it touches the terminals of the secondary circuit. This completes the circuit and provides electricity to the load. With the normally closed type, the secondary circuit is normally complete, and so the load is on. When the current is passed through the primary